Now we'll try to apply some of the theorems from 10.3 to be able to solve problems in circles. It might be a good idea before we go over these together, kind of as usual, possibly pause the video, try the problems out on your own and see if you can come up with the correct answers before we go over them together. In exercises 1 through 4, you want to find the measure of the arc or chord in circle Q. Okay, before I take a look at what I'm being asked in problems 1 through 4, here's what I'm going to do. Just kind of try to find everything that we can find in the circle. So it's given that angle ZQY. This angle right here is 42 degrees. Here's what I can do. These angles are vertical angles. So this would be 42 degrees using the vertical angles congruence theorem. Angles WQZ and XQY should be congruent as well because they are vertical angles. We could take a supplement of 42 degrees to find the measure of either of those angles because they form linear pairs with the 42 degrees. So if you take 42 away from 180, you get 138. That's the measure of angle WQZ and also XQY. Again, they're vertical angles. If you wanted to double check, sorry I'm writing so small, hopefully you can see that. But if you wanted to double check, all 4 of these angles should add up to 360 degrees, and they do. But since angle ZQY is 42 degrees, we could find the measure of the arc ZY because this is a central angle. Actually, all 4 of these are central angles, so the intercepted arc should be the same measure. So the measure of arc ZY is 42 degrees. The measure of arc WX should also be 42 degrees because angle WQX is a central angle, and then its arc would be 42 degrees, which then also means that arc WZ, since it's intercepted by the central angle WQZ, should be 138 degrees. And then arc XY should also be 138 degrees. And then since arc WX is 42 degrees and arc ZY is also 42 degrees, okay, we could use a congruent corresponding chords theorem. Since the arcs are congruent, their chords should be congruent. So chord WX should be congruent to chord ZY. Chord WX is 3.6, so ZY should be 3.6 as well. And kind of the same reason for chord XY and WZ, their arcs are congruent, so their chords should be congruent. This is 9.2 for chord WZ. Let's see if we can answer all the questions from everything that we filled out. I think we found everything that we could find. So the measure of arc WX right here, what I have in green, that's 42 degrees. YZ, that's a chord. So YZ right here, found to be, if you can see that, it's 3.6 units in length. Chord WZ, so WZ right here, I have labeled as 9.2 units. And then the measure of arc XY, 138 degrees. I know I found more than I needed to find for the problems, but that's kind of the way that I do things sometimes. Take a look at problems 5 and 6. Maybe pause the video as usual and then see if you can work through them before we go over them together. So number 5, here's what you should notice. SQ is perpendicular to SR. So SQ is a chord, PR, sorry, I think I said SR, I meant PR, but both of them are chords. SQ is perpendicular to PR, so you could use the perpendicular chord bisector theorem. Not only is SQ a chord, it goes through the center, so it's a diameter. If it's perpendicular to this chord, it bisects it. So PT should be congruent to TR. You could set up the equation 2x minus 4.1 is equal to x minus 0.5. And then solve that for x to find the value of x. You just want to use inverse operations, get the variable to one side. You could subtract x from both sides. I'm going to add 4.1 on the same step. So then on the left side, it's x equals, and then on the right side, 4.1 minus 0.5. So that should be 3.6. Find the value of x. You could double check that, by substituting that back into each of the expressions to make sure that you get an equivalent value for both PT and TR, the length of each of those segments in the circle. And you should. And then if you understood number 5, then you should be able to set up number 6. The only thing that you might have trouble with possibly is figuring out what 3x minus 5 is referring to and what 2x plus 1 is referring to. So 3x minus 5 is segment HG, and then 2x plus 1 is segment JH. So again, KI is a diameter. It goes through the center in its chord. It's perpendicular to this chord, GJ. So if it's perpendicular, then it's also the perpendicular bisector. You could set up 3x minus 5 is equal to 2x plus 1, and then solve that for x. Subtract 2x from each side at 5. X is equal to 6. And then kind of like the last example, you could substitute that back into each of your expressions to make sure that those segments are congruent, and they are.